Okay, I'm hoping for a lot of these questions, especially in the basic section, you know what to do. So it's just implementation of the index laws to begin with. So it's just x to the power of 7, times the numbers together, 6x to the power of 5, division and cancelling down. Most of these, I imagine, should be fine. Same with the expand and simplify. If you need to, then you can use the grid method. So maybe on F you'll want to do that so you don't make mistakes. Same thing with the factorizing. Hopefully these ones are the simpler kind of linear, or ones where there's just a number you have to factorize out of both should be okay. The first one that I think is maybe more difficult than the rest is this one, x to the 4 minus y to the 4. Factorizing that completely, you have to recognize that it is a difference of two squares. So the square originally is x squared and y squared. So maybe that's useful for you to write it as x squared minus y squared. And that's more obvious, maybe, that it's now a difference of two squares. So with difference of two squares, you do one plus the other, and then one minus the other. So if you were to expand that, you get x to the 2 times x to the 2, which is x to the 4, and then x squared times minus y squared, and x squared times positive y squared cancel out, and then y squared times minus y squared is minus y to the 4. The reason it says factorize completely is because you're not done. Here we have x squared minus y squared, which is another difference of two squares. So this one's more obvious, I think, because they're actually obviously squares, but that would be x plus y, x minus y. So that's what I was looking for completely factorizing. If I just run through the rest of it, just any ones which are things that I see issues with. I think whilst it's written as an obvious divide times, then you'll know what to do. It's when those things start creeping into other things, like written as fractions with more than one part. So here it's just 3 minus 2, so x to the power of 5. Over here you do the 3 times the 4, 12, and I think that's x to the half times x to the minus half. That makes x to the power of half plus minus half, which is 0. So that just is x to the power of 0 or 1. So f would just literally be 12. This would just be telling the difference between halves and negatives. So like fractions are roots, remember, so that is 25 to the power of a half, or the square root of 25, so 5, and not negative 5, because to the power of a half only gives you the positive power, the positive square root, sorry. 4 to the power of minus 2 would be 1 over, so this is just 5, this would be 1 over 4 squared. Okay, with some of the more complicated ones, so 9 to the power of negative a half, I would do it in stages if I were you. So do the minus first, so 1 over 9 to the power of a half, and then it becomes 1 over 3. Minus 5 to the power of minus 3, again I would do 1 over, do that bit first, and then you can simplify that or expand it, I suppose. Minus 5 to the power of 3 is 125. All of those you can check with your calculator, but I would recommend doing it without a calculator, just because often these are letters that you can't check with your calculator, so you need to know the rules. This is just practicing using surds, so for example that would be square root of 4 times by the square root of 7. By splitting that up you can write it as square root of 4 is 2 root 7. As I say, that's not one of those things which comes up very often, but occasionally you get a mark for not using your calculator to solve these things, or giving your answer as an exact value when your calculator would round it for you. I think all of these, the calculator will do it right. So even if I chose the last one, which looks the most complicated, the calculator will still deal with that relatively well, I imagine, and it will just give, nope, not even that one. It's not going to give the answer as a third. So let's do that one. That's 25 times by 8. So that's 25 times by 4 times by, oh, I should have just done 100. So that's 10 root 2. That one is 9 times 2, so 3 root 2. And then that one is 36. So that's 6 root 2 minus. So 10 plus 3, take 6, is 7. I'm shocked that this didn't do that in one. Let's just check. 7 root 2 is the same thing as I had before. If I take away... oh, I've already gotten rid of it. I think that was the same thing twice. Maybe I've got it on the wrong setting, but a lot of the time the calculator will do those for you and simplify it. This is where it gets to the kind of intermediate. This is the bit where a lot of people will start making mistakes, either with this or with the ones which end up with negatives or fractions. So with these, you want to separate it. So you've got that as your first term. Let's just write that out. 6x to the 4 over 2x. So 6 over 2, or 3. X to the 4 over x is x to the 3. And take your time, because these ones really do make a difference. And when it comes to differentiation, if you are fluent with it at this point, when it comes to differentiation, this part will be done easily, and then the differentiation is what you can focus on. And they'll all be very similar. I'll do f as well. So 9 over 3 is 3. X to the 5 over x is x to the 4 minus 5 over 3, just leave it as a fraction. And then x cubed divided by x is x squared. I like to have fraction, even if it's an improper fraction, variable, and then power, index form, so that when it comes to differentiation, you times by the power, and then reduce the power by 1, and everything has got its own thing. You could write this as 5x squared over 3, but I think in this form it's just easier to do subsequent calculations with, especially differentiation integration. I'll do one of these, just n, just choose a random one. If you know that you're going to get 6 answers out, or 6 terms, then I would just do 2x times these, 2y times these, and then 3 times these, and add them all together. But I recommended this, so I'll just show you how I would do that with this question, by completely ignoring all of the lines that are drawn there. So 2x plus 2y plus 3, and then x plus 6. The reason I put the pluses in is because then it's really obvious what the sign is inside. 2x times x, 2x squared, 2y times x, 2xy, again put the plus in, x times 3, 3x, 2x times 6, 12x, 2y times 6, 12y, and 3 times 6, 18. When you've got that, you can combine together, for example, these two, because they both have x's, but everything else can't be easily combined together, so you have to leave that. So 2x squared plus 2xy plus 15x plus 12y plus 18. Normally in these questions, if you've got that, you're going to have more than one, and stuff is going to cancel out. So just do one at a time, keep it neat and tidy, and then you can cancel out what needs to be cancelled out. With questions like this, kind of awkward fractions involving fractional powers, or this one's going to end up with negative powers, it's the same as it was before. So if I do g, I'm going to do 9 divided by 3, which is 3, and then x squared divided by x cubed, so 2 minus 3 is minus 1. And I would leave it like this, because more often than not, it's going to be useful for differentiation integration. Don't write this as 3 over x, although that is correct. I would write that as 3x to the minus 1, because then it's easy to times by the power and reduce the power by 1, for example. 15 over 3 is 5, and then x squared. So by leaving it in index form, you can easily do the next calculation, calculus, whatever, integration, differentiation. For h, we're going to get 5 over 15, so just write that as a third. X over x cubed is x to the minus 2. Okay, so 1 take away 3. Leave it like that. Next one, 3 over 15 simplifies to 1 over 5. And then x squared divided by x cubed is x to the minus 1, so 2 minus 3. And again, that I would leave it like that, because then when you come to doing integration, well, you can't integrate this, but when it comes to doing differentiation, you can do that easily. Rationalising the denominators, you can check on the calculator. This one seems interesting, so I'm going to try that one. 2 on the top, leave it, and then expand the brackets. 5 times 2. 5 times root 3 is 5 root 3. Minus root 3 times 2, so minus 2 root 3. And then minus root 3 times positive root 3 is minus 3. These, I always treat surds like unknowns, like constants. So it's like 5a take 2a would be 3a. So 2 over, I don't know why I'm writing in pencil. Doesn't matter. 10 take away 3 is 7. And then 5 take away 2 is 3 root 3. Now you can multiply that by, let's write it like that, 7 minus 3 root 3 over 7 minus 3 root 3. So you're not multiplying by 1, so you're not changing the value, but 2 times 7 and then 2 times 3 root 3. You could leave that factorised. And then make sure when you're doing 2 terms times 2 terms that you're expanding it properly. So you should have 4 terms in the end. 2 of them will cancel. 7 times 7 is 49. And then the 7 times negative 3 root 3 and 7 times positive 3 root 3 will make 0. And then you have 3 times 3 times 3. Okay, what I'm doing there, that's the 3. That's 3. And then you got root 3 times root 3, which also is 3. So 3 times 3 times 3, and it's minus because one of them's minus. And then simplify, 14 minus 6 root 3. And then 49 take 27 is 22. We can, they're both, or everything's divisible by 2. And this is the kind of one where there's very little need to do that, because I'm using my calculator again. I think I've got it on some weird setting, but normally if you put this into your calculator, the 2 over 5 minus root 3, 2 plus root 3, let's see if it does it. It would normally, yeah, I've got it on some strange setting. Is that right? Fix? Norm? Who knows? Let's try that. No, I don't want that. Can't tell you. Normally when you have this, it will write it as a surd there. Who knows what's going on? I'll have to look at that. When it comes to the exam questions, some of these are taken from the new specification, some of these are taken from the old specification, but you'll see that these are the old specification ones, and not a lot of the new specification questions are only chapter 1, so you'll see a lot of these kinds of things being used later on. I would maybe point out this one, so 32 root 2 is equal to, 32 is a power of 2, it's 2 to the power of 5. times by root 2, which is 2 to the power of a half. Okay, so that's the index law, is knowing that the fractional power is a root. And then you add those together, you get 2 to the power of 5.5. So A is 5.5. I do wonder, I'm doing it again, it's not gonna, yeah, it's definitely not. Maybe it's like this. I should really just give up. But 32 root 2 is 45.25, and what did I get? 2 to the power of 5.5 is the same. When it comes to the slightly more tricky questions like this one, we've got 8 to the power of 2x plus 3 in the form 2 to the power of y. So what you've got to do with that is recognise that 8 is a power of 2 and write it as such. So 2 to the power of 3, that's 8 to the power of 2x plus 3. And then it's using the index law of a power to expand that. So that's 3 times by 2x plus 3. These are the same. So that's 2 to the power of 6x plus 9. So that means that is y. So y is 6x plus 9. Okay. Then there's some intermediate questions. It's not this one. That should be relatively easy. That's just y is 3. It's this one. This was what I was talking about before with using the index laws backwards. So 2 to the power of x, fine. But 4, you have to write that as 2 to the power of 2, x plus 1, and then expand that bit. 8 is 2 to the power of 3. So you've got 2 to the power of x plus 2 to the power of 2x plus 2. I've just about to write 8. So then you would get 2 to the power of x plus, and this is the bit you have to separate into 2 to the power of 2x, sorry, times 2 to the power of 2. Okay, it's using the multiplying one. You normally would simplify by adding these powers together, but we're going backwards. And the reason we're doing that is to, actually I don't think I needed to write that as a power of 2, is to write this as a quadratic. So this is going to be 4 lots of 2 to the power of 2x plus 1 lot of 2 to the power of x minus 8 equals 0, and then you're going to solve that like a quadratic. So maybe I should have left this one for the next one, but it's 2 to the power of 2x is 2 to the power of x squared. Yeah, so this is 4 lots of 2 to the power of x squared. This is 1 lot of 2 to the power of x, and then 8. So it's like a quadratic because it's got an x something squared, it's got a something, and it's got a nothing. So 4, 1, and minus 8. So who knows, maybe that was supposed to be a third. Should really look at that. But that's going to be one of my solutions. 2 to the power of x equals this, and the other one is 2 to the power of x equals this. 2 to the power of x can't equal that because it's negative. Maybe that's tricky. Maybe leave that because it would require some later knowledge. But that's the idea, is that this 4 to the power of x plus 1 can be rewritten and then separated using that. And here you've got to the answer, but without exponentials you won't solve that. And that's it for those. I haven't done every single question, but hopefully some of them you can either use what I've said, or they're very easy and you can work them out. If you need to ask anything, these are all questions from the book, so you can find them in the book in chapter 1. and then use, it's not called exam solutions, what's it called, solution bank, and then the exam questions at the end, there is a mark scheme. Okay, so thank you very much. Let's do chapter 2.